No, we're going to do two sections. So today is going to be a little bit longer, but we are finding zeros. And again, we have calculators. We can graph polynomials, and you can find approximately where all the zeros are. But we want to know exactly where the zeros are, which means we have to use our algebra skills to actually find the exact zeros. So sometimes, like yesterday, those zeros were nice numbers. Maybe it was a really nice -1, or maybe it was a really nice -3, where it's crossing the axis. So those zeros turned out really nice. Maybe it was a nice fraction, like, I don't know, the 7½ That's a really nice fraction. But maybe today, one of the zeros today is a crazy decimal, an irrational decimal, okay? Crazy irrational, that's something where it's like 2 plus radical 3, all right? So it's a crazy irrational number. And we get these kinds of zeros when we have to use the quadratic formula. So sometimes today, we may have to use the quadratic formula, and so that may come to pass. So we'll see how we do that. However, it's always a good idea to see if you can factor first. All right? As always, rule number 1. We want to look to see, can I factor? Because that's always the easiest thing. So looking here at number 2. Looks complicated, but it's a trinomial. It's got 3 terms. And so I want to go ahead and just try to factor double bubble and see if I can do it. What is 4 times 8? 32. 32 is 1 away from 33. So I want to keep that. 4x squared times 1x squared gives me 4x to the 4th. And then also, what times what is 8? 4 and 2, but 8 and 1. I want to keep the 8, and I want it to multiply. So I want a -8 and a -1. How do I know if I factored that correctly? Is that inside and outside? Yeah, check that inside and outside, just to make sure. Here we have -32x squared and a -1x squared, and that would give me my middle term right there. So I did double bubble that correctly. Now, both of these, I can go ahead and set each bubble equal to 0. And that's going to allow me to find the zeros when we set the whole thing equal to 0. Technically, this should just be equal to 0. Sorry, that's we're finding zeros. All right, I'm going to find what x is here. How do I get x squared by itself? How would I solve it? Add 1, divide by 4. So I have 4x squared equals a +1. Then I'm going to divide by 4, so I get 1 over 4. And then what do? Square root both sides. What do you need to remember when you take a square root? Ah, very good, plus or minus. Okay, so we get x equals plus or minus. What is the square root of 1/4? 1/2, very good. The square root of 1 is 1. The square root of 4 is 2. So we get plus or minus 1/2. Over here, again, I want to get x by itself. What should we do? Add 8. So we have x squared equals 8. And then square root both sides. What do we need to remember? Plus or minus. All right. So we get x equals plus or minus radical 8. Okay, ladies and gentlemen, really quick here. Simplifying square roots. 8 breaks apart into 4 times 2. And what is the square root of 4? 2. And then that radical 2 stays behind. All right. So 2 radical 2 is a crazy, irrational answer. And so what we're getting here, we're getting a real nice rational fractional answer and 2 irrational answers. So this is an irrational, 2 irrational zeros, And here we have 2 rational zeros. For a total of how many zeros? 4. Okay. So factor first is always a good rule of thumb. If it looks like something you can factor by hand, it's the easiest thing to do. Okay. Here on number 4, we have how many terms? 4 terms. 4 terms. That is factored by grouping. So we split those terms and we look for GCF. What is the GCF of the first 2 terms? What can we take out?
3x squared.
3x squared. Very good. If I take out the 3x squared, what's left behind? X minus 5. On the last 2 terms, what can I take out of both of those? Negative 4. Always take the sign along for the ride. All right, if I take out a negative 4, what's left behind? X minus 5, which is nice. Now, once again, we have here 2 terms. What do they have in common? Yeah. So we take that x minus 5 out in front, and what's left behind? 3x squared minus 4. All right. And then from here, we can set each bubble equal to 0. So we get x minus 5 equals 0. We get 3x squared minus 4 equals 0. And then we can solve for our zeros. So we get x equals 5. That's the easy rational. One rational answer. One rational fractional. What about over here? What's happening here? Add 4. So 3x squared equals 4. Divide by 3. So we get x squared equals 4 over 3. And then square root. Don't forget the plus or minus. All right, so let's see. I guess I need a little more space here. Yes, yeah. So the square root of 4 is 2, and we'd still get a radical 3 in the denominator, but we're not allowed to have radicals in denominators. So what do we have to do? Yeah, rationalize. So we multiply top and bottom by radical 3, which gives me 2 times radical 3, or 2 radical 3 in the numerator. What is radical 3 times radical 3? Just 3. Radical 3 times radical 3 is radical 9, but the square root of 9 is just 3. Okay. Okay, so there we go. There are 2 answers, plus or minus 2 radical 3 over 3. Is this a rational or irrational answers? Irrational. 2 irrational. It's irrational because it's totally crazy. That radical 3 in there makes it irrational. Okay? Rational fractional here, 5 over 1. Real nice fraction. No crazy radicals. And again, this is a total. There's 2 and 1 makes a total of 3 zeros. Okay. So now we can do the same thing when we have a polynomial that cannot be factored. When we have a polynomial that we can't do by hand, for instance, this has 1, 2, 3, 4, 5 terms. I can't factor that by hand. And so then we have to go to the rational root theorem to help us out. So we're going to do our little list, our plus or minus p over q's. What's the, oh Lord, I do not want to list all the factors of 60. It's insane. All right, you know what we're going to do? We're going to use our calculator to help us out because, look at here, the factors of 60, look how many there are. These are all the there's like 15 factors of 60. It's ridiculous. All right, I'm not about that. Okay. So
why don't we do number 10?
Number 10. Well, I am, but I wanted to do 5 this way. 5 terms. All right, let's move forward. Plus x to the 7 minus 23x squared minus 3x plus 60. All right. So again, if we can't factor by hand, then we can go to our calculators and find one that's nice. So do we have a nice one? 4? Yeah, the 4 is pretty nice there. So it looks like, let's use 4 in synthetic division to help us simplify this polynomial, bring it down a little bit for us. Let's see, 1, 1, negative 23, negative 3, and 60. All right, so completing our synthetic division here. And we should get a remainder of 0, which is very, very good. And so from there, I have my function can be written. If I had a 0 of x equals 4, what bubble did it come from? X minus 4. Very good. So x minus 4. And what's my quotient? 1x cubed plus 5x squared. Good. All right. So x cubed plus 5x squared minus 3x minus 15. So now, when you look at that blue polynomial there, what can we do? Factor by grouping. Very good. It has 4 terms, and that's going to do factor by grouping. Real nice. All right. So to find the zeros, I have x minus 4. That's going to stay. Now, just factor by grouping here. What comes out of the first 2 terms? X squared. All right. And it leaves behind x plus 5. All right. And then what comes out of the last 2 terms? Negative 3. And what does that leave behind? X plus 5. Beautiful. And then in there, we see we have a GCF of x plus 5. So I have my x minus 4. My x plus 5 comes to the head of the class. And what's left behind from there? X squared minus 3. Very good. All right, and then if I want to find the zeros, I can set each bubble equal to 0, which here we get x equals 4, x equals negative 5, and then this one, x squared minus 3 equals 0. You get x squared equals 3, and you said what? Plus or minus 3? Radical 3. There you go. Okay. So yes, we would take a square root of both sides. So we have 2 rationals and 1 irrational answer. And this is something, you know, we can approximate it, but Delta Math's going to need you to be exact. So watch, let's see. I can trace and type in radical 3. And we get a 0. So you can check your answer. Which is next? Okay. So negative radical 3 is the other one. And there it is, right there, crazy 1.7, yada, 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 yada. Okay? All right, questions on that? Okay. So then, let's do number 8. All right, I can do my little plus or minus list of P over Q's on this one. What is my P term? No. 19. P is the constant term. And so what are my factors of 19? Yeah, 1 and 19. No others there. What's my Q term? Yeah, the Q is the 1 in front. There's just 1 for that. And so our list of possible factors would be 1 over 1 and 19 over 1. Yep, so plus or minus 1 and plus or minus 19. All right. So that being said, which one do you want to try? You want to try 19? Did you type it in the calculator? Oh, let's type it in the calculator because I don't want to waste my time. I don't know about you, but I certainly don't want to waste my time. All right, so I'm going to type it into my calculator and do a little graphing check here. All right, now which one do you want to try? 1. I'd like to try 1. All right, we're going to try 1. Test 1. Let's see. 1, 5, negative 25, and 19. All right. Synthetic divide. And I got a remainder of 0. which means my polynomial I can rewrite as, if my 0 was x equals 1, what bubble did it come from? X minus 1, all right? Times my quotient. What's my quotient? X squared plus 6x minus 19. Good. Now, when I look at that, it has 3 terms, and I'm going to ask myself, hey, can I double bubble that? And no, I cannot double bubble that. And if I cannot double bubble that, then I know I'm going to get irrational answers. And if I cannot double bubble, what do I have to use? Quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right? So, write it down. So to find the zeros here, we get x equals 1. Over here, I have to use my quadratic formula. X equals the opposite of b plus or minus the square root of b squared. I'm going to do in my head, which is 36. B squared minus 4 times a times c. So that's a 1 times negative 19. You can write it all out if you want, but I try to use my head as much as possible. All right. Are you good, or did I do too much? You're good? Okay. All over 2 times 1, which is just 2. Okay. Now, in my calculator, let's see, negative 6 plus or minus. I'm going to do under the radical. So 36 minus 4 times negative 19. So I put the whole whatever's under the radical. That is radical 112, all divided by 2. So 112. I need to figure out the factors of 112, the perfect squares. So I don't know about you, but it's sometimes nice to have my list of perfect squares. 1, 4, 9, 25, 36, 49. 6, thank you, 64. That's 800, 981, and 100. Okay, that's probably enough. All right, so inside 112, if you take the square root of 112, and we learned this last year in geometry, all the factors of 112 have to be less than this. Okay, so we only need to check the perfect squares that are less than 10. So 112 divided by 9? No. 112 divided by 4? Yes. All right. So 112 turns out to be 4 times 28. And what is the square root of 4? 2. All right. So we get x equals negative 6 plus or minus. The 2 escapes. That ain't right. There's another 4 in there.
Yeah. There's. I was going to say it's 16.
16.
You skipped 16.
Oh, I skipped 16. That is so funny. I totally skipped 16. I was like, wait a minute. There's another 4. So, hold on. 112 divided by 16. 7. Funny. I have to check. So you have to check all the numbers under 100 or under 10. So it's like 9, and then 8. 14. 112 divided by 7. There it is, 7 and 6. So you have to check all the numbers, not just the perfect squares. Pretty fine. Okay. So it turns out that it is 16 times 7. And what is the square root of 16? 4. So a 4 escapes and the 7 stays behind. And that 2 is dividing each term. So I like to split it up just to make sure I reduce it correctly. All right, negative 6 divided by 2 is negative 3. And here, what's 4 divided by 2? 2. So we get 2 radical 7. So there are our 2 irrational answers. Negative 3 plus 2 radical 7, and negative 3 minus 2 radical 7. That's a lot of work. Well, so, no, because we have also not only rational and irrational answers, but we're going to turn the page. Complex zeros. I don't want to do all of these. Let's just do number 3. So, complex zeros, rational, fractional, irrational has crazy radicals in it. Complex numbers are the imaginary things. All right? So, yes, we can still get imaginary answers as well. All right? And so, always, can we factor first? Okay? And that's always where we're going to start. So we're going to do number 3 here. And I look at x to the 4th minus 16, and I think, can I factor that? You actually can. It double bubbles. We haven't done too many of these. What times what is x to the 4th? X squared times x squared. And what times what is negative 16? Yeah, negative 4 and positive 4. And if I want to find the zeros, we set each bubble equal to 0. And then we can solve for x. So x squared minus 4, what do? Oh, we could double bubble. I'm just going to add the 4 actually. And then square root both sides. So I get x equals plus or minus 2. All right, that's a nice rational fractional answer. What happens on the right side? What? Minus 4, so we get x squared equals negative 4. And then I need to square root both sides. Yes. So we get x equals, now we have a negative under that radical. That's where the I comes from. Remember, I is the square root of negative 1. And so whenever we have a negative, an I is going to come out. What is the square root of 4? 2. And what's the square root of negative 1? I. All right? And so we get plus or minus 2I. So here we have 2 rational answers, 2 rational zeros, and here we have 2 imaginary answers for a grand total of 4. All right? Okay. Fantastic. Let's turn the page. I don't want to do that else. We're going to do number 10. So once again, I look at something like this and I'm asking myself, hey, can I factor by hand? It has 4 terms. Can I do factor by grouping here? So I can take out the 16, but then I would have x plus 3, which is not x minus 2. So it actually cannot be factor by grouping. Okay, so sometimes you can do factor by grouping. All right, so because I can't do factor by grouping, I am going to use the rational zero theorem to create my little P over Q list. Oh, but I don't want to, 48 has 37,000 factors. So I'm going to just go to my calculator. Because, time is of the essence here. X cubed minus 2x squared plus 16x plus 48. And we're going to use our calculator to help us out because there's literally 16 factors of 48. All right. So I'm going to look at my calculator and I see my nice little graph here. And it is something, oh, wow, that's interesting. It only crosses right there at negative 2. So that's what I'm going to have to use to get me started here. So if there's only 1 0 that it's crossing at, what does that mean? Yeah. So there's 1 rational 0, and then there must be 2 imaginary zeros. Because it's not crossing anywhere else. Okay. There will be a plus or minus something I in there, yes. All right, so we got a 1, a negative 2, a 16, a 48, and I'm going to do my synthetic division. All right. So I can rewrite my function as if the 0 is x equals -2. What's the bubble it came from? X plus 2. Good. And then I have my quotient. What's my quotient? Good. Good. And again, I'm asking myself here, 8 times 3, 6 times 4, 12 times 2. Can I double bubble this? Doesn't double bubble, so that means I have to quadratic formula, Q formula. All right. Here, I know that x equals -2. That's one of my zeros. But over here, I got to use my quadratic formula. So x equals the opposite of b plus or minus the square root of b squared. What is b squared? 16 minus 4ac. A times c, 1 times 24 is just 24. All over 2a. 2 times 1 is just 2. So I do a lot of that in my head. On my calculator, I'm going to do 16 minus 4 times 24. So I have 4 plus or minus radical -80 over 2. What's that negative do for me? Gives me an I, okay. 80 is 10 times 8, you're right, but I want perfect squares here. 16, yeah. So 16 times 5 is 80. That's one of the math teacher facts that we learned. Only because it comes up so often. Okay, so what is the square root of 16? 4. So a 4 and what's the square root of the negative? I. So 4i escapes. The radical 5 stays behind, and each term is divided by 2. And that cleans up to be yep, 2i radical 5. Beautiful. Again, we can only simplify the numbers that are the same type of numbers. So these are regular old 4s and 2s. You couldn't, if this was like a 6, you couldn't reduce the radical 6 and the 2 because one's totally radical and other's just regular decimal. So that's really nice about it. Okay. Yep. So these are our 2 imaginary solutions. 2 imaginary, 1 real. All right. So quadratic formula is definitely a possibility today. So be a little bit careful. No, I did. I'm pretty sure.
Mine's still at the same percent.
Yeah, don't worry about the other assignment. It should be 3:11. Yeah.
I can't believe we like the shade.
All right. Oh.